Hi everyone, and this is the Algebra 2 Unit 2 review. So I'm going to go through these problems. I'm doing the paper version of it, but kind of works the same, and I'll explain as we go. So let's begin. So number 1, the entire graph of function f is shown in the figure below. Write the domain and range as intervals or unions of intervals. So we see here that this function over here, right, lives in this area, and this one in this area. So basically we need to first write our domain. So our domain are the x's. And we see the x's only cover this area over here and this area over here. And they have this big separation in the middle. So our domain basically is going to be x is greater than 5, but equal to, because it's a solid circle, so greater than or equal to 5. X is greater than or equal to -5. And you see it goes all the way up to -2, but has an open circle, so it doesn't include it. So we have -2. Then you have or, that's the or is the union. We see that it starts up again at 2, but it's greater than, not equal, because it says open circle. And then once again, it goes all the way to 4, and you have another less than symbol. So this here represents this area right here, where x is greater than or equal to -5, and x is less than -2. Or this area over here, where x is less than 2 and x is greater than 2, but x is less than 4. And remember, since they're open circles, there are no lines under our symbols. Graph the equation, the -3 times the absolute value of x. So these are your absolute value symbols. This is like the parent function, so our vertex is going to be at 0, 0. So when I go to my graph, I can go ahead and put a point on 0, 0. This right here, this a term, is my slope on the right. My slope on the right is telling me I have -3 over 1. So if I go down 3 and over 1, there's my slope, down 3 and over 1. Then you repeat the same process, just opposite on the other side. And this is what my absolute value function will look like. All right, on this one has an adjustment or a transformation or a translation to the x coordinate of our vertex. And remember, we do whatever the opposite is. So if this is -3, that means our vertex is now 3, 0. So I go to 3, 0, which is right there. Now, our slope on the right is -2 over 1. So if I zoom in, I go down 2 and over 1. Down 2 and over 1. Same thing, down 2 over 1, down 2 over 1, and this is what our absolute value function is going to look like on that one. So all you have to do is really you just have to graph one point on each side, and then Alex will do the rest for you. All right, number 4, we have to graph this one. This one we can see our adjustment is going to be a -3. Remember the opposite of this, 2. And our slope is 2 over 1 on the right side. So I go to -3 and +2, which is right there. And my slope is 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And there is my function. All right, number 5. Suppose the function f is defined for orbital numbers as follows. So this is a piecewise function. So basically, where x is less than 2. So here is 2, so I'm going to draw a line there. And I'll go ahead and make this my blue function. So less than 2 is over here. And notice that this does not have a line under it, so for blue, it's going to have an open circle when it hits that line. Now let's go ahead and make this one our green function. And it says x is greater than or equal to 2. So that would be on this side of it, because they're both using 2. And then this one is going to have a closed circle where it hits 2, because you see how it has an equal sign underneath. So we can go ahead and graph this by using y equals mx plus b, right? The slope-intercept form. So I have a negative 2x plus 3. So this is my y-intercept, and this is my slope of negative 2 over 1. So with my blue pen, I'm going to go ahead and graph this. My y-intercept is positive 3, and my slope is negative 2 over 1. So down 2 over 1. Down 2 and over 1. But you see how this is going to bring me right on that line? So I put my open circle. So now when I graph this, it's going to look like this. As far as the green one's concerned, this with my y equals mx plus b is x minus 3. This is my y-intercept, and my slope, which is that 1, is just 1 over 1. So I start at a negative 3, which is right there, and I go up 1 over 1. Up 1 over 1. See how I'm filling in that circle right there? Because it hits it. Up 1 over 1, up 1 over 1, up 1 over 1. So now I'm going to draw my line from this 2 over. And I have to get rid of the points that are in the blue area. And it wants to know if it's continuous. Well, where 1 ends, if I trace it where 1 ends, it picks up exactly where it is with no breaks at all and keeps going. So is this function continuous? The answer is yes. All right, translate each graph as specified below. So A, the graph of y equals x, so this is this one right here. That is the parent function of absolute value. We need to translate it to be this. Well, remember, whatever you do to x, you do the opposite. So we're just going 2 to the left. So I'm just going to take it, go 2 to the left, 1, 2, and I'm going to start it right there. Now you see this has go up 1 and over 1 to get there, so we're going to do the same thing. And that's what that one would look like. Now on the next one, part B, it has absolute value of x minus 5. See how nothing's going to the x? So we don't move the x at all, but we have a negative 5 outside here, so that is 5 down. Whoops. So I just go 5 down right here. And there is my translation. All right, on number 7, below is the graph of y equals the absolute value of x. Translate it to make it this. Well, this just says I'm going to go ahead and take it, and I'm going to go positive 3, negative 2. So 3, 2 is my new vertex. So I go 3, 2. So right there, and then it's just going to look like this when it's translated. Oops, sorry. I just realized that that's 3, negative 2. So it's right there. It looks like this. All right. Number 8, the function as defined as 3x squared plus 3. The graph of f of x is translated vertically down 4 units, and it becomes the graph of function h. Find the expression for function h. All right, so basically, h of x, okay, is basically this one when it goes 4 units down. Right, so when we go 4 units down, right, that's going to change this right here, correct? Because whatever's with x goes left and right. So our h of x is just going to be the same thing, 3x squared. But when we go 4 units down, we're just minusing 4, so it gives us a negative 1. And that's all it is. Number 9, graph the parabola. So to graph this parabola, we see that our vertex is going to be 1, negative 4. So I go ahead and I can find that I have a 1, negative 4. 1, negative 4 right there. That is my parabola. Now, this 3 here, okay, we can go ahead and graph this by using a chart. We know we have a 1. We're not going to worry about the 3 right this second. That's more advanced. So then we go 0, negative 1, 2, 3. So when I make my table of values here, I have an x, I have a y, I have a 3x minus 1 squared minus 4. So now I know I have a 1, negative 4 here. So if I put a 0 here, 3 times 0 minus 1 squared minus 4, this is 3 times negative 1 squared, which is just 3 minus 4, so that is a negative 7. So then we have a 0, negative 7. Nope, I think I made a mistake in math-wise. Hold on. 3 times 0 minus 1 squared. Oh, that's what it was. Right? So now this is 1. All of this times 3, which is 3, and 3 minus 4 is negative 1. I knew it wasn't going down, because if that was 0, negative 7, that would have been over here. So my parabola would have to start going this way, and I immediately knew I made a mistake because this is positive right here. Then I have a negative 1. 3 times negative 1 minus 1, which is negative 2 minus 4. So this would be 4 times 3, which is 12 minus 4 equals 8. So that would be, so we have a 0, negative 1. I have a negative 1, 8. So that's what that'll look like. When we do the other side, we'll get the same answers. And this is what my parabola is going to look like. When you graph it in Alex, the first thing it's going to say is, hey, right, the steps are 1. When you click the parabola tool, you click the vertex. 2, make sure it's going up or down. Then click again. And then 3, click on another point. And that'll put your parabola in the right place. Okay, number 10. Graph this parabola. Well, we are not in vertex form, and this would be very difficult to do math in, right? If you start doing your negative b over 2a, right, that would be a 30 over 6, which is 5. You have to plug 5 in, and then you have to find your other y. So we're going to go ahead and complete the square. To complete the square, I have to get rid of this 3, right? The way I'm going to get rid of this 3 is I'm going to divide both of these terms by 3 and leave this 72 alone. When I put the 3 in front, 3 divided by 3, that just leaves me an x squared. Negative 30 divided by 3 gets me a negative 10. The x is still there. Then I have a positive 72. So now I take my middle term and I divide it by 2. Negative 10 divided by 2. That equals a negative 5. So right now, I already know, in the end, my answer is going to be 3x minus 5 squared. Right? When I square this, it gets me 25. So this technically is going to be x squared minus 10x plus 25 plus 72 equals, well, on this side here, I have to put this 25 on this side. But because of this 3, it's 3 times 25, so that's 75. Then when I minus 75, that gets me a negative 3. So this is my equation. So now I know my vertex is 5, negative 3. So I have a 5, negative 3. So it's right here. This is my vertex. Now to graph this, what I'm going to do is make a table of values. I know I'm at 5 and a negative 3. And I just use some values, x and y. I'll put a 4 and I'll put a 3 here. And I can do that. I can use it in this form if I want. X minus 5 squared minus 3. So 3 times 3 minus 5, which is a negative 2 squared minus 3. And we can put this in a calculator. So negative 2 squared is 4. So 3 times 4 is 12 minus 3 is 9. All right? When I do the 4, 3 times 4 minus 5, which is negative 1 squared minus 3. So 3 times negative 1 is 3 minus 3 gives me 0. If I do it on the other side, I should get the same answers. 3 times 6 minus 5 squared minus 3. Well, 6 minus 5 is 1, and 1 squared is 1. So 3 times 1 minus 3 is 0. So you see how we get the same answers. So now I can go ahead and graph this. I have a 4, 0. So right there. I have a 3, 9 all the way up here. Same thing on the other side. I have a 6, 0, and I'll have a 7, 9, basically. Then I can go ahead and graph my parabola. Remember, as this number here gets bigger, this gets narrower, okay? All right, so now we have number 11. Write the quadratic function in the form of basically vertex form. This is vertex form. So what we do is we have to divide by 2. When we divide by 2, I get 2x squared minus 6x plus 11. I take my negative 6, move it over here. Negative 6 divided by 2 is negative 3. And a negative 3 squared is 9. So I have 2x squared minus 6x plus 9 plus 11 equals, well, 2 times 9 is 18, so that's an 18 right there. Right? We went like this, boop, to get to that. Now, in factored form, this is just x minus 3, right there, minus 3 squared plus 11 equals 18. I subtract my 18. So 2x minus 3 squared minus 7. So my vertex is positive 3, negative 7. That's the vertex. So I have a positive 3, negative 7 right there. If I go ahead and make my table of values, we have a 2x minus 3 squared minus 7. And I know that I have a 3, negative 7 right there. So I use a 2 and a 1, and I'll use a 4 and a 5. If I use the 1, 2 times 1 minus 3, which is negative 2 minus 7, so it's 2 times 4, which is 8 minus 7, is 1. If I do the 2 times 2 minus 3, which is negative 1 squared, so that's 2 minus 7, gives me a negative 5. If I use the 4, 2 times 4 minus 3, also a 1. 2 times 1 is 2, minus 7, negative 5, and we see the this will be a 1. So I have a 2, negative 5, a 1, 1, oops, 1, 1, also a 4, negative 5, and a 5, 1. And parabola-wise, we're going to look like this. All right, and now finally the last one. The quadratic of the graph of a quadratic function with the vertex 1, 3 is shown below. Find the domain and range. So the domain of all parabolas, because this is going up, but it's also going this way and this way forever, is the domain is going to be all real numbers. But the range is basically here, right? You see how it's going from this line up? So our range, where this is 3, is just going to be y is greater than or equal to 3. All right? And that wraps up your practice test. Okay, and see all the different answers here. Right? This over here, that is function notation. Set notation. Basically, when we go back to number 1, another way to write this is wherever you see this, the equal sign, you can write a square bracket for an equal sign. So basically, it's just saying that is one range. This here means equal to. This one just means less than or greater than. And then it's doing it all in that kind of notation. All right, this would be something that you would have learned in Algebra 1. Okay, so we use parentheses for greater than or less than. When it has the equal sign, we use a hard bracket. All right. So if you have any questions, let me know.